Alright, so today we are looking at a LeetCode problem that's called the smallest K-length subsequence with occurrence of a letter. So we can read the problem definition here is that you given a string s, an integer k, and a letter, and also an integer with the repetition. So your job is to return the lexicographically smallest subsequence of s of length k that has the letter appear at least repetition times. So if we start with just sort of defining what is the lexicographical smaller string, we have it right here. So basically it's, let's see if we can have one here. If I have a string that is B, C, D, E, okay. A, B, B, D, E. So the last string here is going to be lexicographically smaller than the first string. And the reason is that you just look at, you walk through the string and you just look at each element at that position. So first it's the same, right? And then B, they're also the same, but then we can see that B here is before C. So that means that this one is lexicographically smaller. It doesn't really matter what comes afterwards here. This one's going to be smaller anyway. Okay, so there's an example here that shows with delete, and then you're supposed to find out, okay, so the string has to be 3 characters long, and it has to include the letter E. So we can see that the output here would be EET. So what I did first was look at how to solve this without all of these constraints, like without the occurrence of a letter here. And there is a pretty good example of this at, what's it called? Geeks for Geeks. So they have a site where they show you how to find the smallest K-length subsequence from a given string. That is the lexicographically smallest one. And what you're going to do in this LeetCode problem is just a variation of this problem. Alright, so before I start with looking at the code and solutions, I thought I'd start off with exploring a little bit about how to reason about getting to a solution for this problem. So the problem is the smallest lexicographically subsequence of length k. So you have a string, and your task is to find the lexicographically smallest string. So let's say you'd have to find one that has the length of 3 here. So the first approach that you could have is, of course, to simply construct all the possible subsequence and then sort them. So in this case, you'd start at the letter D, right? And you would create one that's DON, DNA, DLD, and so on. And then you'd start at the letter O, and you'd create the ONA, OLD, and so on. Yeah, as you can figure, that's going to take quite a lot of time to do that. So if you want to do this in a more efficient manner, you could kind of have an approach that uses a stack. And we'll see more in the code why that works out well for us. But let's look at this string here. Okay, so if I wanted to do this in linear time, one way I could do is, I guess I could start by, okay, I walk through this string, right, Donald Duck, and I'd start with taking the first letter D here, just like in the simple approach here. Okay, I start with D, and then I'm going to check, okay, would it be better for me to start at the letter O? No, it wouldn't. Then I can add another I'll add this O. So first I'll have D, and then I check if O is better. No, it's not. Okay, then I'll just add that, and I'll have DO. Okay, then I'll look at the letter N. Okay, is N better than any of the than the previous letter I looked at? Is it better than an O? I mean, lexicographically, is it smaller than the letter O? Yeah, it is. So it makes sense that I'd remove that O, and now I'd have DN. Remove the O. Okay, and then I'd check again. Okay, would it be even better to start with an N than with the letter D? No, it wouldn't. Alright, and then I would continue onwards, and I would look at the letter A. Okay, is it better if I'd have the string that is DA? I mean, is A smaller than N? Yeah, it is. So then I'd have this string, remove the O. Oh, sorry. Remove the N. And look one more time. I'd say, okay, is A better than the letter D to start with? Is it smaller? Yeah, it is. So I'd remove the D. Okay, so now I got nothing left. I have no other elements to check for. And then I just keep going like this. Okay, so L, is it better to start with the letter L than the letter A? No, it's not. I'll add that. And then I'll reach D, and I'll be removing the L and putting the D, so I would have AD. And I'll just keep going like that. But I have to, of course, make sure that I also check that I actually have enough letters left to construct the substring. And that way I can do it in linear time. And this is the approach that we will be using for this solution. Alright, so now let's look at how to write the code. So I'll run this in the debugger here. So now we're just going to find the lexicographically smallest string first. Okay, so we have the same string here, leetCode. Okay, we have 4 as our length of this string. So what we're going to use is a stack. And basically what's going to happen is we walk through the entire string here, the leetCode. And if we start off, we got nothing, so we got to push something onto the stack. So we take the first letter here, which is leetCode. And kind of show you what sort of the idea here is. So leetCode, we're going to walk through that entire string, and as we walk along through it, we're going to first we're going to take, if it's empty, we're going to add something onto the stack here. So we'll take the L here. Then we're going to come back here, and now this answer stack is not empty anymore, right? So now we're going to look at the next element in this. It's easier if you consider the string as a vector here. Now we're going to look at E. Okay, so it's E smaller than what we have at the top of our stack, which happens to be the letter L. And yeah, it will be. Then we have one more constraint, and that is to make sure that there's enough characters left in this entire string for us to make up the substring, so that if we reach the end there, we still need k number of characters, right? But what we do here is we check if what we are currently looking at, if it is lexicographically smaller than what's at the top here? And if it is, we simply remove it. So, okay, L is going to get popped here. And then what we do is we add that's E instead from here. And then we just keep going. So this one's not smaller. So we're going to take that one, put it on the stack. So let's put it down here. And then we're going to look at T. T is not smaller. So we're going to put that on the stack too. So you have to think of the stack as being reversed here because it's just too messy to keep it the other way. So T, this is the top element right now of the stack. Okay, so then we're going to come to the letter C, and okay, we're going to compare that to the top. Okay, and we're going to see, okay, that is smaller than than T. So we're going to remove that one, and then we're going to look at this one. Now this is the top. And we're going to compare C to that one. And we're going to see, okay, so C is smaller than that one as well. And same story here, right? So what we end up with then is C. And we clean out the stack. And now all we're going to do is we're going to insert that C. And of course now we only have so many letters left, so we need to add them all. We're not going to pop anymore. So we can kind of just walk through this and see it in action here. Okay, so now we put the first L in, and I'm going to see, okay, is E smaller than what's on the stack? So yeah, it is. So we're going to pop that. And then we're going to push the E onto the stack. So now we have that E in here. And E is not smaller, so we're going to push that one. You can see that it's there. And then we just keep going here. Now we got that EET. All right, and then we reach here. So we have T, we're going to compare T to C. And that's smaller. So here we're going to do a lot of popping. We're going to clean it all out here. See, now it's only one letter left there. So now it's empty. And then we push the C. And now we got no possibility to pop anything here because of this second condition here, which says that, okay, there is actually not enough to finish. To create a substring of the length k if we keep pushing popping things away. So we just put it all on there. Okay, so now we have code in here, and this is we're watching here. The top element actually is E here. It's just the way that the debugger represents this. So what we need to do is pop it and then reverse that string, and then we're going to get code. And I think it helps just to look at this, because what we're going to solve in the leetCode question is basically just the same thing, but with some more constraints. So now we have some more constraints that we got a letter that has to be in there, and it has to be repeated a certain amount of time. Right. Okay, so now let's return to the problem that we had here with the extra conditions here, that we need a occurrence of a letter that has to occur a certain amount of times in this substring that we're going to return. So I have it set up here, and I think we'll try and just walk through the code once, and I'll show you what it does and how to solve it. Okay, so now we're going to try for one of the test cases here. leetCode, 2 repetitions of the letter E, and substring size should be 4. So as you can see here, the code is very much the same here. We're still traversing this string here. We are keeping a stack that we're using, and we are popping and pushing letters onto that stack. But what we've introduced is these 2 extra counters. And what we're doing here is we're keeping track of this letter that we need to repeat a certain amount of times. So we start off with counting, okay, how many letters are remaining in the string if we are at the start of the string leetCode. Okay, there are 3 letter E's. And how many do we already have in our answer? So what we're going to do here is we're going to do the same thing here. Okay, so we start by pushing the letter L, just like before. But here we're keeping track. Okay, so if the letter that we are looking at here, if we're walking through this string, happens to be the letter that we need to repeat, we update these counters here. So in this case, we don't have to do it because it was the letter L. But okay, so we'll keep going here. So now we're going to compare L to E, which is of course going to be, E is going to be smaller than L. So what we're going to do is we're going to pop that letter L first. So here's some additional code to keep track of this. So it will make probably better sense what's happening inside of this if statement once we get to the case. It'll be easier to understand what's happening here. So okay, we'll just keep running here. So okay, we emptied out that L, and now we're gonna push the letter E. So okay, I skipped this line here. This won't come into play. This section here won't come into play in the case that we are looking at, the string leetCode. This will never happen, but there are other cases, and I will show you one of those later, and it will be more apparent why that section is needed. Okay, so right, we're pushing the letter E onto the stack, and see, we're updating this counter that we have here. And same here, we're updating the other counter as well. So now there are only 2 letter E's remaining since we've used one of them, but we got one in the answer. All right, so now we're looking at E again. We're at L-E-E, so the second E here. And this while loop will not be used here because E is not smaller than E. So nothing to do here, we just push the other E onto the stack. So now we got 2, and we increase that. We have 2 in the answer. It means also we have only 1 E remaining from where we are standing. All right, so now what we're going to look at is we are at L-E-E-E-T, so T is not smaller than any of the letters that are in the answer, so nothing's going to happen here either. See that? And yeah, we're just going to push that T. E-E-T, okay. And now we're at the letter C from leetCode. And yeah, that's going to be smaller than what we are currently have at the top, which is the letter T. And T is not one of those, that special letter that we are looking for. So we just pop it off. But now we can see that C is smaller than what's at the top here. So this part comes into play here? Okay, so what is it we're trying to achieve here? Well, so what we're looking at here is how many letter E's are there remaining, because we need to have a certain amount of letter E's in the substring that we're about to return. So we can see that we have 2, and if we're going to pop this letter off from the stack that's in here, we're going to have 1 less. So 2 minus 1, that's 1. And there is, how many letters is remaining from where we are standing? How many do we have left? Well, we have 1. So 1 plus 1 is, that's not less than the number of repetitions. So this is fine. We can pop this letter E off here. And we just decrease the counter. Alright, so now we have 1 letter E left. And C is smaller than the letter E. So we're going to come in here again. Okay, so now we're at the second E here. That's the one that we have in our answer, in our stack here. And we're trying to compare if the C, should we take the C instead of this first one here? I mean, that it would be fine. We would still be able to get a substring that's the length of 4, like in the Geek for Geek code that we looked at. But it won't fulfill the criteria that we need to have this many letters E left. So here we can see, okay, we have 1 in our answer, minus 1, so that's 0, plus 1, so that's 1. And that's not, we won't be able to fulfill this criteria here. So what's going to happen is we're going to step out of this while loop here. So that letter remains. So if we didn't do this, it would have been popped off, and we would get an incorrect result here. So now we just push the letter C on, and then we keep going here. So I think at this point it will just do the same as in the Geek for Geek version here. We won't need any of the logic here anymore when we're stepping through here. So now we're going to just keep running here. We're going to get, okay, ECO is on the top now. And then D is smaller than O. So we pop that off. So D is not smaller than the letter C. So we don't do anything more here. And then we just add the D. And then we're going to take the last letter here. So now I think this criteria is not fulfilled anymore. So we don't do anything more here. All right, ECDE. Okay, cool. So now we're done here. And then we just reverse that string. We can see that ECDE. Yeah, that's from the second E, and then the C, and the D in E from here. Cool. So that fulfills that criteria. We got what we wanted here. Okay, so let's look at another example here, and I'll show you why what is needed. That's this section that's here. Why is this needed? Okay, so we get this string instead, which has 3 A's and then 2 B's. Oh, sorry, 3 B's. And the letter that we need to have is B, and we need 2 repetitions of it. Okay. So what's going to happen is we're going to just fill this up with the letter A here. So now we got 2 A's. Okay. and the size here is 3, and we already have 2 A's in here, and we're not gonna want to pop anything off here either, because now we're looking at the third A, which is not smaller than the A that was in there before. So if we didn't have this constraint that we need to have the letter B appear twice, I mean the smallest, lexicographically smallest one would be 3 A's, right? Okay. We won't have enough space to push the letter B onto the answer stack if we don't remove the ones that are in here. So there are 2 letters in here. There are none of the needed ones, and we need to have 2 of them appear. So we're going to add is 2 plus 2, which is more than 3. So what we do is remove the one that we took. So now we're going to push on the third A here, and I'm going to come back here. I'm going to do the same check here. So okay, now we got the letter B, which is the one that we actually need, but we're not going to push it or pop anything off here, because B is not smaller than what's at the top, so nothing happens here. But this thing is going to do the popping for us instead. So now we're going to see, okay, the size here is again 2. There are none in here, and we need to have 2. So this is going to be 2 plus 2 is more than 3, that's 4. So we'll remove that one that we pushed in before, and then we're going to get our letter B in here. Alright, cool. ABB. And then what's going to happen here is, okay, B is not smaller than the previous B, so we're not going to remove that. And now this is not going to have to do anything for us, because now we have enough space here. So okay, the size is still 2, but we got one of the letters that we needed in here once. So 2 minus 1 plus 2 is 3. It's not less, sorry, it's not bigger than 3. So we don't do anything, and then we get this second B into our substring here. So that's how that works. And then we just run through that, we'll get this ABB at the end here. I don't think we need to look at all of that. Just reverse it, and then, yeah, it's ABB. Alright, cool. Alright, so I just wanted to show that the solution has been accepted on leetCode as well. So here you can see it's the same code that we've been walking through. Yeah, so I guess that's it. I also wanted to give ChatGPT a chance to try this out and see if it can solve this problem for us. I've been reading a lot about it, and I think it's quite interesting, and I just want to try it out and see if it can do this. So this is what I'm going to ask it for. Write a C++ function that returns the lexicographically smallest subsequence of a string S. The subsequence should be the length of K. The subsequence should have a letter C appear at least repetition number of times. So let's see what it does with that. Okay, yeah, see it's typing up a lot of stuff here. This function first counts the number of occurrences of each character in the index. It then checks it in. So this, I think, does not solve what we want it to do. We can try it out once. And yeah, I have already tested this before, when this looks like the same result that I got before, that it didn't work. So I have done some prep work before, but I thought I'd show it off as well. Here, ChatGPT version. So ChatGPT. So we try this out with the first string here. Did get the signature here, right? But it doesn't do what it's supposed to. Let's remove the other samples here. So now we're just running the ChatGPT version here. Let's see what that gives us. So EEE from the length string leetCode, that is the length 4, and has to have at least 2 E's repeated in it. So yeah, this is not what we would have expected. Let's look at the test case again. Okay. So this is we would have expected the ECDE to be output from this. And instead, yeah, so this is wrong in my comment here. It should actually be ECDE, of course, here. I think I just left that comment from before. So this obviously did not work. I don't know if I want to dive into the actual code that it has written. It uses some sort of a map here to count, keep track of this special letter. And then it has a loop that goes through. Okay. Yeah, this obviously doesn't solve the problem, and I tried to get it to generate another better answer for us. Counts the number of occurrences of each. Okay, so we only got 3 letters back when we asked for 4, so that isn't good at all. And we got what? 1, 2, 3. Yeah. See, so it hasn't mapped them to something incorrect. Oh. So K should be. Here's a function of string S. That is the length K contains the C at least now. So yeah, it has not done the right thing here. This is not the same as the first version that I got when I asked this, so I don't really know what to do more with it. But yeah, it just goes to show that it's not for sure that ChatGPT will be able to help you out all the time. Yeah, in this case it failed rather miserably. All right, that's it. Well, hope you guys thought it was fun to watch this part 2. I mean, it's been all over the news, so I thought it was just fun to show this off as well. All right, thank you for watching.